meegebracht. Zo ook onze volgende spreker die uit Zwitserland komt en aan de Universiteit van Zurich professor is. Die zocht een Nederlandse uitgever voor zijn boek, Elephants in Space. Nelleke heeft hem daarbij geholpen en dat is gelukt. Er is een Nederlandse versie van gekomen die heet Hallo daar, de zoektocht naar leven elders in het universum. En over dat onderwerp gaat hij ook praten, over hoe planeten ontstaan, hoe het werkt daar allemaal. Allemaal zaken waar ik helemaal niets van weet, dus ik ga 20 minuten zeer geboeid luisteren en vraag jullie een warm welkom te geven aan Ben Moore.
Hello, everybody. So, one of the greatest achievements of mankind, really, I think, has been our identification of our place in space and time in the universe, and the understanding that the universe had a beginning, and that it had an end. And we understand quite a lot of what happened from the Big Bang until today. And that was enabled by the invention of the telescope 400 years ago by a Dutch optician. Now, when you point a telescope at the stars, or you stand outside and look at the stars, it's an amazing feeling. And one of the second great accomplishments of our civilization, I think, one of the great results of astrophysics and science, is the discovery that almost every star we look at in the night sky has its own planets, own solar system, its own worlds orbiting that star. That's quite amazing. So next time you look up at the stars, just imagine what might be out there. And that's the topic of this little talk. It's imagining what is out there in the universe. Based on science and biology, physics, chemistry, geophysics. Just last year was an incredible discovery on this topic. The first Earth-like planets have been found orbiting other stars. Planets similar to the Earth, made of rock, at the right distance from their stars, such that water can be a liquid. So how do we do this? How do we find planets orbiting other stars? They're so faint, they're 1 billion times fainter than the stars they orbit, and the reflected light from these worlds is swamped by the brightness of the star. So we have to use clever tricks in astronomy to determine if a planet exists orbiting another star, and to determine what it's made of, its size, its density, and what its atmosphere is like. So I'll just show you how planets are typically found. And this technique here is called the transit method, and it's led to the identification of thousands of new worlds out there in our galaxy. This is the transit of the sun by Venus, and you see the light there is indicated on the right. As Venus passes in front of our star, it blocks some of the light. A tiny fraction, a tiny fraction of a percent, but it's enough to be detected by a telescope. So by looking for dips in the intensity of the starlight, we can infer the presence of a planet. And by monitoring that star over years, we can calculate the orbits of those planets. If they're eccentric, we can calculate how far away from the star the planet is orbiting. And from the amount of light that's blocked, we get a measure of the radius of the planet, the size of the world that's blocking that starlight. And if we put all this information together, this is a catalogue of all the worlds that have been discovered so far. These are real orreries of real planetary systems orbiting stars out there in our galaxy. And the diversity is enormous. It has surprised all my colleagues in the field, because we've found everything. There are planets orbiting 2 stars. There are stars with more planets as our own solar system. Our own solar system is in here. It's close to the center there. Which one is it? I don't know, actually. I've forgotten now. Now, as these planets orbit the star, the gravity of the star is keeping that planet in orbit, but the planet also exerts gravity on the star and causes it to wobble backwards and forwards. The star, our sun, actually moves at about 1 meter per second thanks to the pull of Jupiter and the Earth. That's walking speed. But astronomers can detect a star moving at this speed, light years away, and from that motion, we can measure the mass of these planets, how heavy they are. And putting that together with the size, you get the density. We can figure out if these worlds are made of rock, or made of water, or gas, like the gas giants, Uranus, Neptune, Jupiter, Saturn. So we can learn an awful lot. We can do a lot more, in fact. We can actually image the molecules in the atmospheres of these worlds. We can measure day and night. We can measure the climate. We are searching at the moment for biomolecules, indicators of life on these other worlds. In fact, one thing we're looking for, as well as oxygen, obviously, which is mainly produced by living organisms with our biochemistry, we're also searching for forest fires on other worlds, because forest fires produce nitric oxide that we can detect with our telescopes, and things only burn if they have been alive. Putting all this together, in our galaxy alone, there are 10 billion worlds like our Earth, orbiting stars like our Sun, and those worlds, 10 billion, are orbiting their star at the same distance as our Earth, such that water on its surface will be a liquid. Not too close to the star where the water is evaporated, not too far away that it's frozen. 10 billion habitable planets in our galaxy alone. So, where are all the aliens? Well, you know, in the 50s and 60s, there were lots of great photographs like this, and UFOs are spotted all over the place. Unfortunately, today, you know, at this time, there were maybe 100,000 cameras on our planet. Today, there are 2 billion high-resolution video cameras in people's pockets, and not a single good photo of an alien or a UFO. So, is the universe, is our galaxy empty of life? Are we the only civilization in it? Are we the only life in our galaxy? That would be very sad and scary to me. Or is our galaxy filled with life, and for some reason, they're just avoiding us? And I can't think of one reason why they might not come here. Seriously. There are many solutions to the Fermi paradox, and they're best talked about over a beer later on tonight. But for now, let's just imagine what alien life might be like. Imagine an alien. Think of what comes into your head. What do you see as an alien? How do they look? Maybe one of us might think they look like a goat, but I think most of us have this sort of picture of an alien, and that's very sad. This picture here is a byproduct of Hollywood. All the aliens in movies look pretty much like this, probably because it's cheaper to dress up a human in a funny costume. So what's the reality? What could an alien look like? Well, on our planet, there are 1 million species of animals with a brain, and any one of those species could evolve over 1 million years. It's intelligence to our level. That's how long it took us on our evolutionary path. So an alien could resemble any one of those or something completely different. I like to think an alien might be like an octopus, for example. These are super smart creatures. They have brains, a neural network distributed throughout their body. They can move all their limbs independently. They can solve puzzles. These are smart creatures. In 1 million years, their brains might evolve to be larger than ours. If we are not here anymore, these might be the next overlords of our planet. In fact, the vision of science fiction writers was more creative and more technically correct than any vision of a film producer. H.G. Wells, over 100 years ago, wrote about Martians from Mars. Everything he wrote in this book was scientifically accurate then, and it still is today. His biological picture of aliens feeding off the blood of other living creatures was accurate. And at this time, it was common knowledge that life existed on other worlds in our solar system. There was a prize offered for 100,000 francs at the time for the first person to communicate with life in our solar system. And Mars was actually excluded from the competition because it was going to be too easy. H.G. Wells was correct. The Martians would have come from Mars because it was a dying planet. At that time, it was seen that there were ice caps in a desert around the equator. And today we know this is correct. Mars is a dying world, even though some time ago it was very similar to Earth, a water world with oceans and a climate like our own planet, but for some reason Mars ended up as a wasteland with no atmosphere today. There may be traces of life on Mars still, or even underground on Mars, but there are other worlds in our solar system where life may be abundant, alien life or life like us even. One of my favorites is Enceladus. It's the icy moon of Saturn, so far from the sun that its surface is minus 150 degrees. It's frozen, cold, has an icy crust. But beneath that ice is a warm ocean of water, with more water than in all the oceans and rivers and lakes on Earth combined. It's warm, it's kept warm from the radioactive decay of the rocks deep inside of this planet and this moon, and also by the gravity of Saturn that squeezes it as it orbits around. When Cassini flew past a few years ago, it detected the vapor jets of water being squeezed out from the cracks in the ice. What might be there? We're only just exploring the deep oceans of our own planet, and life down there, life in our own ocean, to me is astoundingly amazing and alien as well. We don't need to look further for alien life. What is in the oceans is already quite incredible. This creature here, this cephalopod, it evolved telescope eyes 50 million years ago. It has dual lenses that it can focus things from a large distance away. Quite amazing. This here, I would like to be this creature, actually not a goat. I would like to be the eternal jellyfish because it lives forever. When it gets old, it says, I don't want to die. It reverses its life cycle and grows back into a baby polyp and then begins again. And this cycle just carries on forever. Try that. Well, this creature is ubiquitous all over the planet. The famous water bear, it can survive anything. It's been taken into the vacuum of space and exposed to minus 270 degrees centigrade, brought back to Earth, and it's fine. It just carries on its life. It could make the journey to Enceladus, carried there on a piece of space rock from Earth, or life could have evolved there independently. Perhaps Titan, another moon of Saturn, gives us a different concept of what alien life could be like. It's only been visited once by a probe from Cassini that was dropped through the atmosphere, and it took a few photographs before its battery died. It's extremely cold there, water would be frozen, but it spotted these wonderful lakes and rivers of liquid, not water, but hydrocarbons, liquid ethane and methane. So life on such a world would have a very different biology. Wouldn't be based on carbon, it might be based on silicon instead, which would be stable in the presence of ethane. It might breathe in hydrogen instead of oxygen and metabolize that with acetylene instead of glucose. And it would breathe out methane instead of carbon dioxide. So you can't get much more alien than that. There will be new missions to these moons of Saturn in the next decade to explore them further. But what about out there amongst the stars? What could alien life be like? I think one of the most visionary concepts of an alien I've seen has been from the late artist Giger, who created the alien. Metallic exoskeleton, telepathic with lightning-fast reactions. Could that be possible? Could a metallic creature exist out there? Why don't we have a metallic exoskeleton? It could be lighter and stronger than what we have today. Is that possible? Well, there is one species of creature on our world that actually has managed to make metal in its structure. This is the scaly-foot gastropod. It has an iron pyrite-coated shell and scales of pyrite here to protect it. So evolution is a very haphazard thing, and it's only been explored once on our world, but there are worlds out there where different evolutionary paths may have happened. What about those lightning-fast reactions that the alien has? Or like Neo from the Matrix that can see a bullet and just walk out the way. I wish I had reactions that fast. Our reactions are limited by our clunky neural network and our nervous system, which works by conducting electrical signals from one nerve cell to the next. It takes about 1/10 of a second for us to register something. Neo, or the alien, could see things happening close to the speed of light, and to them, the world looks like it's happening in slow motion. Is that possible? Well, all we have to do is replace these clunky nerves and these axon cables with metallic wires. Then the signals would travel along our nervous system to our brains at the speed of light. We would have reactions as fast as Neo. It's perfectly possible. It's an evolutionary path that hasn't been explored by creatures in our world. Well, until just a couple of years ago, when actually a bacteria was discovered that had managed to build from its amino acids and proteins in its genetic code, it can construct wires, nanowires, that conduct electricity in and out of their body. So it's a possible evolutionary adaptation of aliens. If we go back to that slide I missed here, we also want to be able to move quickly. And you think that it would be impossible for life to evolve cogs and wheels. Well, this little creature discovered a few years ago, this nymph, it actually has interlocking cogs that spin around in its back legs to enable it to spring quickly and extremely accurately and rapidly. So evolution on Earth has produced some amazing things, but there are many unexplored paths. And I talk a lot more about those in my book. So what could life be like out there amongst the stars? Stars are not all like our sun. There are bigger stars and smaller stars. Life around these worlds is probably not so exciting because big stars don't live for very long. They burn through their fuel very quickly and last about 1 million years. There are plenty of stars like our sun. There's 100 billion of them in our galaxy, give or take a couple. These small red dwarf stars are the most abundant star in our universe. Much smaller than the sun, they don't burn as hot, their glow and their light is in the infrared and red wavelengths. Life on a planet orbiting such a world would be quite different. In fact, for a planet to be in its habitable zone where water could be liquid, it would be so close to its star that it would be tidally locked. What that means is that the orbit of the planet, its spin, is synchronized with its orbit around the star, just like the moon is around the Earth. The moon is tidally locked to our planet. That's why we only see one side of the moon. All planets around those red dwarf stars will also be tidally locked, so one side will face its star. There's about 400 billion red dwarf stars in our galaxy, and most that have been looked at so far have worlds orbiting them. So their worlds might look like this. With one side facing their star, there might be a desert. The backside is always going to be freezing cold at a temperature of outer space, minus 200 degrees, but there will be a ring around the equator where life could exist. But there would be no night and day. The sun would be fixed in the sky permanently. Wouldn't be very good for our sleep patterns, at least. There might be water worlds with water on one side and ice on the other, so life might be confined to the oceans. And then it's an interesting question. Could intelligent life have a space program if it evolves in water? Because you have to be able to melt metal, and that's hard if you're in the ocean. What would it look like once we eventually travel to these worlds, I hope in a few hundred years? What will we see? Well, a landscape like this we're used to on our planet, with all the colors we have evolved to be sensitive to. But a red dwarf star doesn't emit any green or blue light. It only emits yellows and reds. And that's okay because photosynthesis can still work if they have plants like our own. But there will be no greens and blues to reflect. So what we would see is a landscape like this, a red sky with no light reflected from the plants because all the red is absorbed. It would look black. In fact, if we wanted to think ahead and set up a business, for example, we might trade our art with aliens from such a world. And I've set up an art business for this, no, only joking. But this is one picture we might sell to our alien friends and convince them of our talents. We think this is a very colorful, beautiful picture. But to an alien on a red dwarf world where their eyes have evolved to be sensitive only to the red lights, such a picture would look very dark, and they would think our art is depressing, and they probably wouldn't be interested in buying it. 10 billion planets like our Earth in our galaxy. That's enough for one each. I'm willing to sell you a whole planet, let alone a patch of the moon. Just talk to me in the lunch break, and you can have a world of your own. Which would you choose? A holiday home, a planet all to yourselves. Would you choose a world that orbited 2 stars because you're romantic and want to have 2 sunsets a day? Well, it sounds nice, but be careful, because gravity is notoriously chaotic, and your planet might not be stable in this configuration and might get ejected into space, so you might skip this sort of a world. You might be greedy and want the biggest planet out there with the most real estate. And there are worlds out there that are 20 times the size of our Earth that have been discovered. Plenty of room for your holiday home here, but try walking on this planet with a gravity that's 3 times as strong as Earth. It'd be very hard to move more than a few steps. Life on such a world, the size and scale of life is governed by gravity. So things are going to be small and flat and scary on such a world. So I wouldn't go to this one either. You might choose a world a bit more like Mars, with a lighter gravity. Be quite spectacular. Trees could grow 1 kilometer high on a small world like this. Or perhaps you would choose an empty world, a world with no life, just to be safe, but there would be no atmosphere to breathe, but that's okay. You could just take a drop of water from our ocean, put it in this ocean, and in 10,000 years you would have an ecosystem of bacteria and microbes that would have oxygenated the atmosphere. So you'd have to be patient for a little while before you could live there. Perhaps when we go out to the stars, we might not find alien life as we like. It might have evolved as we might evolve in the future into more of an android machine that is completely contrary to what we might want to find out there. Given all these worlds, they're all different. The atmospheres are different, the gravity is different. I don't think we would be happy on any of these other worlds. We would not be able to sleep, we would not be able to breathe, we would not like it at all. This is what we have. This is where we've evolved to live, and it's where we're going to be living for the next few 100 years, 1,000 years at least. Our Earth is all we have, and we should really take care of this. And that is the end of this little story. Thank you very much.
Thank you, Ben. Wonderful, wonderful. Elephants in Space. En ook in het Nederlands dus. Hallo daar. De zoektocht naar leven elders in het universum. Vooral die vissen helemaal onder op de zeebodem intrigeren. En al die andere dingen. En het feit dat je vroeger met 3000 camera's wel ufo's zag en nu dus niet meer. Dat houdt ons nog wel even bezig. Wij gaan even naar een filmpje kijken. En dat is van en over Velofsky. V is al